Hey everyone, thanks for joining. We are for now waiting about 24 minutes until the actual ceremony will begin. People are assembling in San Francisco, so we need to fix last couple of things with the video from there. While we do that, we can chat a little here. Yeah, would be great, but it's hard to get the visa, unfortunately. And we spent all the hackathon budget for the prizes. So if I or Vita would to go to San Francisco, we would have less money to give out for agent fight and research. So yeah, it's a more important goal. Okay, while we wait, let's talk. So raise your hand if you wanna say something. Who do you think will win? Any bets? Humanity will win? Yeah, Alex, you're totally right. I guess we already talked yesterday. Everyone is super exhausted. Yeah, we talked yesterday like for 4 hours or something like that, like with a brief pause to listen to Martin. By the way, it was a great talk. The YouTube video is available. The YouTube translation didn't work due to technical reasons, but we uploaded it today, so you can all rewatch it. And I really advise you to rewatch it. It's a great talk. to navigate longevity industry main bottlenecks and basically like what do we need to do to actually have a little better chance to defeat aging. Hey JP, are you uh, at home or are you in San Francisco by any chance? Probably he's not even hearing us. Yeah, also guys, we already received 20 feedback from 20 people. Thanks a lot. So if there is someone on this call that did not submit feedback, uh, please, please do it. I will share it in this chat, and I think while we wait for the results, it's a good couple of moments then when we can do that. Um, Alex Decan suggested us to check BIO.XYZ lab stock price. But yeah, I mean it's um, it grew a lot on the news about NLRP3 inhibitor success, but not the BIH success, the success of the asset of some other company. So like all the companies with this asset, they kind of their valuation raised. Um, oh yeah, Laura, thanks a lot. We need to post it on socials. I think we did some posts. Let me just post it as well. Good idea. All right. Yeah, I did the social media post and I will post the link here in the chat if you could like it and repost it. Oh wow, I see the Frontier Tower. Frontier Tower is with us. We can see the screen. In about 15 minutes, we will start the official hybrid ceremony, both live and online. Right now we just talk here. And yeah, for everyone, I just posted a Twitter post. If you can go via the link I posted and like it and share, it will help a lot. We'll get some more viewers who will actually see that some of you maybe may have won. And yeah, I see. I know that at least one person who is among those who already joined has won something. Suspense. Who it might have been. Yeah, I see the YouTube comments. Friendship will win. I do agree. Friendship and humanity, that's the most important part. At the end of the day, we are not here for the money. We are here to live as long as possible, preferably forever. And HD 0 and a lot of numbers. Hello, Alexei and everyone. So excited to hear about today, and congratulations to everyone. Yeah, congratulations to everyone. Happy to have you.
Hi, everyone.
Hey. How do you feel, Rakesh?
Yeah, great. Bit cold.
Where are you joining us from?
From Central Europe.
Oh, yeah. I'm a little bit in the South Europe, so it's a little bit less cold.
Warmer. Yeah, I bet. So
We're still getting
I'm
set up over here in San Francisco, but Alexei, whenever you'd like to get started, I can go ahead and get this call up on the projector and get rolling.
Yeah, I mean, we start in 12 minutes. So, yeah, and I think we'll start from. So, like, you can put us on at like 1:30.
All right, sounds good. Sounds good.
And Lawrence and Suji will be after us. Okay, good. It looks we have at least one person in San Francisco, which is good.
Alexei, can I make a request?
Sure.
Can you tell me if my Zoom screen is correct? And then I'm going to go on and off quickly. Is it backwards?
Um,
Do you see the VitaDAO backwards?
Yes. No, it's right.
It's right? Okay, because I
Yeah.
see it backwards.
No, we see your beautiful face and we can read, I
Okay,
think,
and you say, okay,
quite
cool.
well. Yeah,
Thanks.
that's fine.
Okay, just going off the screen. Hey, everyone.
See you. We have a lot of interesting news from Laura.
Yes.
Yeah.
After we moved around things many times.
Yeah, I mean, the main thing is our women live longer and healthier lives. So this is
Yes.
the most important. And yeah, small nuances are not, here and there. We can live with that. By the way, on yesterday calls, two people proposed us like with the fundamental tracks and with all the tracks to have some discussions with mentors. And yeah, we discussed it among the orgs. So yeah, we will do some sessions, like each track will have a session. Everyone will be able to discuss their solutions. Mentors will discuss the best solution, the good solutions. And yeah, it would be a good time to kind of get live feedback from everyone. We will come back with this schedule probably, late Sunday, probably Monday. Also, we probably won't be able to ask many questions when we start in 8 minutes. So probably these are last 8 minutes to ask any questions. Then it will be a lot of back-to-back videos and talks. So if you have any questions, now is the time. Maria, I would also add a middle check. What do you mean?
Can you hear me?
Yes.
Yeah, it was I couldn't participate yesterday's session about discussion, but I was thinking on your question right now, like what would you add on a hackathon? And I would add this later just to add maybe middle check on the results, something like this.
Oh, okay, yeah, okay, I do understand. So kind of like a small deadline, not as a deadline, like a sick line or something. Yeah, good idea. Yeah, my track had these opportunities. Like I was always available to talk to at any moment. Several people used it. Dmitry, who's on the call, did use it, and several other people. So, but yeah, it might be a good idea. Hey, Dima.
Hello.
Happy to see you.
Me too.
So, do you have a new, deeper understanding of theory?
Yes. Maybe it's surprising so fast, but yes. Yes, in fact, the whole day today, I was preparing the lecture to the next iteration of our course, Computational Biology of Aging at Tech. And while I'm preparing this lecture, I I I think I understood something about these theories. I think I'm capable to better classify them.
Cool. Cool. This is super important.
In fact, the results of our track was super surprising. I will keep intrigue before my talk, but that was super interesting solutions that I received. The solutions were very different in the style, how they were prepared, how they were. It was interesting how differently participants understood the task. Despite the criteria was quite objective, and even numerical metrics were given. In any case, the exact idea of finding aging theories and articles were understood differently. So I will tell about this.
Yeah, I'm super interested. So I didn't have any time to dive into your track, but I will, have a day off tomorrow, hopefully, and then I will, I want to explore what you've found and like what your participants found.
Yes. From my side, I regret that I didn't have enough time to keep on other tracks. Like, for example, Future of Evidence was super interesting for me. I really excited to know how Alex and Albert managed to overcome it, because in my opinion, that was one of the hardest track, because meta-analysis of uh, on a given topic, meta-analysis of thousands of articles, super non-trivial task.
Yeah, also very interesting. Yeah, we'll see at least a winner of each of these tracks that we are discussing today. But yeah, again, we will have new people joined. We will have some retro sessions, and I mean retro, not the company, but like retro in terms of we would be able to talk with mentors why a particular solution was better than another solution, and like what were the good parts of some solutions that didn't win. So like we learn, like every one of us learn how to be better next time, and like how to fight agent better. Okay, let me check my chats.
Yeah, like I said, if you want 2 minutes here, I think your favorite could do is if you could record a session yourself through Zoom. That some finicky things just with setting it up on my end. So just be able to capture the slides and everything like all here. Folks are open to giving to it as well. I mean, it's been that hard, but if you're able to put it on your end, I think it'd be solid.
Yeah, we are streaming this as well, so it will be in
Oh,
YouTube. But yeah, I think we are recording it as well.
Okay, awesome. Cool. I think I'll get them.
Yeah, don't worry about the screen capture. Okay. Guys, I need to call. I need Uh, we have another postponement of about 5 to 10 minutes. People from San Francisco just called me and said people are just trying to sit down, find seats, find food. So unfortunately, we will start a little bit later. So yeah, we even see people right in the chair. So another 5 to 10 minutes to wait. Sorry, it's a nature of hybrid events like that. It's usually super hard to ask guests to stop chatting and sit.
Oh yeah, quick serious. So, yeah, whatever you guys get started, yeah, can you go and fire that up? That's, I come to this sort of, discussion real quick, someone's called your voice. I just called it. I just called it. So we'll get started around, okay, all right, yeah, looks like, yeah, we're long here, so. I have a question to you.
Hey Vita, we wait for another 5 to 10 minutes until people in San Francisco take their seats, take their food. As usual, you look great, by the way.
Me? Oh, who? Thank you.
Yeah, but
How many of us are there? Not there here. 33. Okay. Does anyone from online would want to share something? Maybe your emotions about the last 2.5 weeks. It would be cool to be in San Francisco. Doubled.
yeah, we can see immortality or death coming from San Francisco.
This should be the book by Sasha Panchin, right?
Yes, yes.
Who has attended his lecture? Raise your hand. Not me. Awesome
Awesome
sleepless
learning time. Wonderful. Yeah, we had the same.
Welcome to Hackathon. Yeah. Are you guys excited about the finals? This was a such great experience. Thank you for organizing. Thank you. Every time you thank us, I do appreciate it. What about you, Alex?
Yeah, I feel like 1 year is added to my life.
Everything. I will thank you frequently.
Oh, Sasha, thanks a lot for participating. And Vincent, yeah, thanks a lot. Okay, let me check if we have any news from San Francisco. Yeah, Bruna, thanks a lot for participating. It's so great to have people all over the world, guys. It's wonderful. I mean, this is the unique challenge that every person in the world has. So like, we might not die from AGI or from climate change. These are like important issues, but the agent kills us with 100%. Like 100% chance at some point we die from agent, unless we develop the technology to fight it. So yeah, it's super nice to see people from all over the world.
Guys, and while we are waiting for San Francisco, we can also share with you what's going to be there after the finals, because actually we have a great program for today in San Francisco. Just to let you know that the finals is not the whole program. We're going to have one more hackathon in San Francisco. So people who joined us today in Frontier, they will participate in kind of what we called ideathon, because we're gonna challenge the ideas of life extension, and it came from our Misha, who was the main idea, the main person who proposed the idea of hackathon. So he knows how to make great ideas, and he wants people to participate in this kind of event. And we hope this is gonna change the map of the community around longevity in San Francisco. So if you're up for there, oh, I can see myself in San Francisco. So if you're up for something like this, please join this community offline as well.
Hello, San Francisco. Can you hear us? Apparently not.
Only me. Oh.
Iteration is important.
Oh, yeah. Hello, San Francisco again. Can you hear us? I hope they can hear us. At least they can see me. But do they know that I know?
Can you hear us now? Alexei,
Yes.
can you hear?
Yes.
All right, perfect. We hear you. You have all the attention on you. Go ahead.
Hello everyone. Thanks a lot for coming. So today is the final ceremony of the hackathon. A lot of people from all over the world, actually almost 1,000 people registered. So a lot of people from all over the world were trying to develop AI agent that would move us forward and accelerate our progress in the fight against aging and death. And today we are proud to present the winners. But again, the winners are not the main thing. Most important is actual progress. It's like, even if you didn't win, we will help you to develop your project further, find new teams, find new teammates. So please stay in touch. Today would be a mostly ceremony, so you will see some of the projects, not all, and most of the projects will be available at the hackathon official website. We won't have much time for questions, unfortunately, so please keep your questions for further online and offline communications. We have very, very tight schedule, and people in Europe want to sleep because it's a little bit late. So we would need to move really, really fast. And most participants who submitted their solutions, given the solutions were not empty or meaningless, basically most of the hackers who at least submitted a solution will get a certificate, which will be super useful and very beautiful. I've seen it. And those who won, we will connect with you on Monday or a little bit later, and we will provide you with details how to actually get the price and all the logistics around it. So let's start. And yeah, let me invite Lawrence from Frontier Tower from San Francisco. Lawrence?
Coming in a sec. Hello, everyone. Welcome, welcome. Do you guys know what you just walked into? This is the Frontier Tower. It's a 16-story building, a vertical village for frontier tech pioneers like you. A big aspect to it, of course, is the longevity aspect. We have a longevity floor on the 11th floor. Towards the end, we can have a tour. Who would like to join a tour of the longevity floor? Okay, great. And we have the intersection of so many technologies. We've got, where is the poster? There's some posters around. So there's human flourishing as well, bringing the heart and the soul, humanity plus technology. There's AI and crypto and longevity and robotics floor. We have also a basement where we do robot fight club. There's a cage where the robots box. And event space, of course, and a gym and sauna and so on. The intention here is to find everything you would find in a small town, but filled with people at the frontier. Have a community where we can accelerate progress together. Wow, I love the infinity mirror. All right, so the longevity floor is a permanent space for people that care about living longer, healthier lives. First of all, by having a space where we meet, we can have the wellness aspect covered. It's easier to be healthy in community. It's easier to be healthy if all the food around you is healthy, everyone is being disciplined. We can keep each other accountable to exercise and all the things, go to bed on time and all the things. So the wellness aspect also makes us more productive in our fight against aging. Then the second part, level 2 of the longevity floor, is more of a biohacking/clinic. So there's a whole spectrum from things like supplements to hyperbaric oxygen therapy, red light therapy, peptides and vitamin IVs and so on. So for some things you need a doctor, for some you don't. We will have a doctor there, and hyperbaric oxygen therapy coming in a few weeks. For members only initially. So I definitely invite you to scan one of the QR codes around and join as a member of the Frontier Tower. It's just $150 a month per year, or 190 per month if you pay monthly. Yeah, and you get all access to the whole tower. And the third aspect to the longevity floor is more around this. People that work to stop or reverse aging fully. So a bit of an incubation aspect, a co-working, cohesion in the community, people helping each other, starting startups together and so on. Cool. Then I would love to also talk about Viva City. I'm not sure if I'm talking about it now or later. Kevin or Alexei? Later? Okay. So yeah, just a quick welcome, and you'll hear from me more later. Thank you very much.
Thanks a lot, Lawrence. So happy to hear you. And the next, I would love to invite our wonderful computational sponsor, Nibius, and very, very interesting and happy and funny guy, Suji, who will announce 3 special prize winners from Nebius. So these are the first winners you will hear today. These are 3 prizes picked up by Nebius from Rapid Adoption Track. Suji, I hope you can hear me. The floor is yours.
Alexei, I can hear you fine. So, 1 second, please. There you go, just 5 slides. I'm not going to bore you with the slides. So very quickly, I'm from Nebius. I do developer relations. We are really happy to be supporting the hackathon. I was just curious, anyone here used or using open source models for your agents? Great, perfect. We want to encourage more people to use open source, and that's what Nebius is all about. Next slide, please. Thank you. No. It's okay, just go next. Just go next. Yeah, that's fine. It's okay. Yeah. I know, right? I should like, there we go. So I figured, I'll just break up the, do like an icebreaker by asking a joke, AI to write me a joke about agents. And this is what they came up with. Next, please. So these are 2 open source models. I just, it's kind of funny how they talk about agents. I'll leave them up here for a second, and you can judge for yourself if they are any good or they are all equally bad. So anyway, please. So Nebius, very quickly, we are an AI cloud provider. We host open source models. You probably heard us on the news, so we've been pretty busy. Next, please. Okay. And a global footprint. We have data centers all over the world and more coming. Basically, the value prop for us is, since we do our own entire vertical stack, since we control our own vertical stack, starting with the hardware all the way to the managing software, that gives us pretty good value prop, price, performance, and reliability, right? That's what we compete on. So one of the product I focus on is called AI Studio. Basically, you can see sort of all the popular open source models. We host all the latest and the greatest open source models. So if you're wanting to run these, actually, we do have a credit for the hackathon. So if you have it, great, try it out. If you want a credit, please come and talk to me afterwards. Happy to set you up. And then maybe this is a slide you probably want to take a picture of. So the credit code, I will give it to you in person. But yeah, so these are all the QR codes for how to go and how to use them, and some example codes and Discord. Yep. So with that, I think that's all the presentation I had. We are going to announce 3 winners from this hackathon. We call them Nebius Prize. So here we go. 3rd place is called Voice of Your Biology by Renaissance Labs. Very good. Oh, there we go. Oh, cool. We actually have them here. Well done. Well done. Great project. And then second one is multi-scale self-updating casual networks by Griffin Labs. They're probably not here. I saw their presentation. It was pretty cool. So that's second prize. Yep. And the first place goes to Longevity Intervention Evidence Tracker, Longevity Pro Hackers. So they are all they'll be all updated on the website. So congrats to all the winners. But more importantly, congrats for everybody who competed on the hackathon, right? Because that's honestly part of the fun. You're kind of in a time crunch trying to build something, which is a lot of fun. And here's one thing I want to leave you with. Just participating is part of the fun. But if you like to keep building, because building doesn't have to end at the end of the hackathon, and if you like to use open source models, I would love to talk to you more, and come and find me afterwards. I'm happy to set you up with our platform. That's it. Thank you, guys. Thank you so much.
Thank you, guys. Thank you, Nugus. Thank you, Suji. And we continue with our first challenge. And the first challenge is called Singularis. And it was proposed by Professor Pertolitsky from Hong Kong. And since in Hong Kong it's midnight, we used the modern technology and we made a video with him. And he would love to announce the winners of his track himself. And I will share with you his, just a second, give me a chance to share something. Professor Litsky here. Sorry, guys, just a sec.
Hello, everyone. I'm Peter Litsky, the challenge master of the Singularis Challenge. I'm here in Hong Kong, and I will not be able to attend in person. That's why you see me on record. And I'm here to announce the winners of the Singularis Challenge. The question arises, what was Singularis Challenge? So I want to remind you that our project is striving to change the way we communicate and store knowledge. We believe that the existing format, the academic papers, is an outdated custom that really slows down scientific progress and specifically our path to immortality. And our suggestion is to annotate the existing papers with a new format, this Singularis format, that considers much more granular pieces of data or like logical operations like hypotheses or conclusions as minimal citable and publishable units. So far, we have an algorithm that does it using LLMs, and the challenge was to build a lighter old algorithm that can do it in a faster and cheaper way. So several teams took on board. Not everyone came to the finish. So we have had a tough discussion of whom we want to elect as a winner. And we decided in the end that we will have one first prize and one special prize. So the fund will be divided between the two teams. And I'm happy to announce the test team who made the best algorithm as the first place in the Singularis Challenge. This site can allow you to test their algorithm yourself. So the second team that we want to award with the special prize is Digital Humans. Their algorithm is a little bit less precise, less accurate, and generally, we wouldn't mention them here. However, we believe that their algorithm can be improved substantially. Maybe they have chosen too complex path, and it wasn't possible to accomplish within a given time. So that's why we want to issue them a special prize. As you can see, both algorithms are still quite inaccurate compared to LLM. However, we believe that the hard work, diligence, and creativity invested by both teams will contribute to the further progress of our project. If you have any interest to collaborate with us down the road, we will be happy to discuss that. And congratulations to both teams, and congratulations to all the hackathon participants. Thank you so much for being here. It was an amazing event. Mortality and progress. Goodbye, everyone.
Thank you, Professor Litsky. Kevin told me that I have mic problems. Guys, let me know if the problem still occurs. And I'm going to show you the winner. And just to explain you, when we have two winners, we're gonna show you only the first winner, just not to enlarge our time of event. And now we go for team test to show the demo video. Just a sec. Share. And here they are.
Hey folks, Vincent and Retro from team here. We're glad to be part of packaging and wish everyone well. So let's start with our demo. As you all know, it's a real problem to navigate through dozens of paperwork. Automation tools exist, but either cost a lot or lack important back reference features. So we propose a solution, deterministic and controllable, made with rule-based logic that constraints and red display options. The core idea behind it is concurrency. Match article against set of concurrent rules, compute hit scores, boost, and denote with post filters and tiebreakers. At the end, we have most probable label for the sentence, with knowledge which rules won, preserving other hits, and total confidence score. So let's look how it works. Here we can upload our file, start parsing, and we see processing stages. And here we go. It's our graph. It consists of atoms, basic and classified units of paperboard. Zoom in or zoom out, we see all the input facts, typos, and their relations. Double-click to read full text, check confidence score, page in original article, and more than that, link to PDF. Yes, for each sentence we store provenance, so we can navigate through PDF easily. Now, what's next? And we have something. We want to add section restricted and weighted rules. It will allow us to collect narrower, but more semantically correct items of the text. More facts from intro sections, more results from results sections. Topic bounded rules. Specific rules for different fields of science, bio, physics, math, or others. Semantic edges, a linking by keywords and context. And finally, LLM feedback loop. You have already seen confidence score that we calculate for each sentence. So for low confident nodes, we plan to push them to LLM, provide existing matching rules and detailed constraints. To ensure that new rules are stable, we will run them against a gold standard set of pre-annotated articles and prevent any drop in confidence. That's it with our demo. Thanks for watching and good luck to all the team.
Thank you, the team. We applaud you. And we gonna have the next challenge. It is the agent theories, right? And the mentor, Dmitry Krukov, is here. Dima, I give you the scene.
Okay, let me share the screen first. And yes, probably you can see my screen, right? What's the
Yes.
slide you see? Okay, I see on the translation from San Francisco. Yes, I want to start with thank you guys. Thank you for choosing our challenge regarding aging theories. I believe this is an important challenge, maybe one of the most important topic in the modern aging theory, I mean theoretical aging, but it is also important for practical longevity because to understand how to create a longevity drug, pure longevity drug that extends lifespan 30 years and more, probably we need a theory. So let's go to the results. So This challenge was guided by me and Simon Station, who is not with us today, but she says you thank you also. And she is very happy that we succeed in achieving good and very interesting results. Just short reminder that this challenge was constructed as follows. The teams of AI masters was given the following tasks. The first task is collect as many aging theories as possible based on the relevant papers relevant to the aging theories. And the second task, extract a specific information from those theories by answering specific questions. And then first and second task were evaluated. The first task was evaluated by random sampling of articles and manual checking if these articles are related to aging theories. And the second task was was checked by the prepared validation data set with manually answered questions. So these are the set of questions. Probably it's not so super important to show them all right now. But what is the important, and what I want to emphasize, that on the first tasks, the metric, the score for the first task was the sum of logarithms, sum of logarithmic terms. And in principle, if you meditate over this formula, you can see that the more papers for the more theories, the more the score. This means that, for example, if you find more theories of aging, and for each theory of aging you found a number of articles, like 10 or more, the score will be higher. And this is how you could maximize the score by finding the maximum number of aging theories. In the second task, you just answered the question, and the metric was just the number of right answers. So, who is the winner? The winner is Diana Zagirova, who performed solo. Applause in chat. Yes, and let's briefly decompose the solution of Diana Zagirova. I just briefly mentioned that Diana Zagirova in task 1 managed to collect 15,000 of articles and absolutely impossible 2,000 of aging theories. Of course, we know in the field that the upper bound of aging theories in 19th, in the last century, in 19th, was the kind of 300 aging theories. Today, with power of AI agents, we collected 2,000 of aging theories. Of course, this is an upper bound, and probably the actual number is lower. But this is how our metric was optimized, and Diana managed to optimize that metric by finding so many aging theories. In task 2, Diana found 3 of 10 validation articles. We label it quite popular aging theories articles in validation set, but probably only 2 teams managed to find 3 of them. The second place in the challenge also found 3 articles. Okay, it could be, but correct answers was given by Diana. The number of correct answers is 20, and second place answered 19 questions according to the labeled validation set. But what is most outstanding, and what we did not plan, we did not ask you to prepare a website with the solution. And that's where Diana surprised us more. That was not a part of the final score, but I hope Vita just in a minute just show you how Diana performed so well that this website become live. Thank you, guys. Thank you one more time. Let's see the solution as a website by Diana.
Thank you, Dim.
Yeah.
Alex, you will
Yes,
share.
I can take it from it.
Thanks.
Sorry. So here is Diana's solution.
No sound, Alex.
Yeah. Can you share it again and select the share sound?
We can't hear it.
So wait a second. Where do I do it?
When you stop sharing and start it again, and then you have an option to share sound.
Oh, I see. Very sorry for that.
Imagine searching for the secret of aging in a jungle of diverse scientific literature, each using different keywords, different terms. But what if we could create a trustable living map of aging theories to the evidence, both scientific and AI use? That's actually the challenge we took on. Our task was to collect aging theories related papers and extract from them aging theories. The biggest challenge here is that actually we don't know how to extract these papers. So there is no single keyword, no single query to PubMed to find these papers. So they are really diverse. The agent theory could be proposed in different parts of the papers, and probably even know the word of theory will be in the abstract. So the high diversity here is the main challenge. That is why I propose the top-down funnel approach. The main idea is that first we start really wide, we try to cover as many papers as possible, then narrow down by filtering with different agents, with different LLMs, to finally found this trustable agent theories related papers to make more advanced, more precise analysis on them. That is how this 5-step agentic pipeline appears. So I'll go through all of them. So first is the literature mine, and no probably should stop here. We just collected a lot of papers. 100,000 papers were collected on this step. Of course, there were a lot of papers that we should filter. The papers go through the full text extraction, and actually the stage 3 is where actual LLMs started to take place. We start with a really lightweight LLM to first filter this large majority of papers, just to filter out papers that are absolutely not related to the agent theories topic, obviously. That's why we use really lightweight LLM to save money, to save time on this step. What we got here, 30,000 papers that were valid for further steps. Actually, the most interesting part is actually extraction of theories from the valid papers. Theory extraction was individually on one paper, and what's interesting here, I extracted not only the name of this theory, but also related mechanisms to further use in the downstream analysis. When we extracted these theories from the papers, actually LLM is very non-deterministic. That is why you see here a lot of filtering steps. The most interesting one probably and the last steps, when we have clusters. Clusters are the name of similar theories, and we try to make more generic names more specific, and more specific names more generic, to kind of normalize the clusters and make them balanced between specificity and really generic terms. So finally here we have out of almost 30,000 initial theories, 2,000 trustable and normalized theories extracted from the scientific literature. And the last part is question answering on the paper, as were asked by the challenge. I apply the RAG approach of retrieval augmented generation. It means that we first create a database of embeddings from the full text of the paper, and then use RAG technique to augment the LLM to generate more trustable responses. So that is a quick overview of my solution on the this challenge. Hopefully it will be the first step on the normalizing the agent theories across different fields, and probably it will help longevity research further.
Wonderful. Applause to Diana. That's quite a number of theories to read, even after the filtering. Okay, Vita,
Yes,
I give mic back to you.
Yeah, sure. Thank you. And I think we didn't mention that Diana got 3,000 USDTs for this challenge. It's all hers. And for the next challenge, I would love to give the mic to Alex and Albert, who was the mentors of Future of Evidence challenge. So Alex, Albert, are you with us?
Yes. Yeah, let me share screen first. Yeah. Yeah, okay, I can see the slide, right?
Yes.
Okay, perfect. So Alex and I are working on the Future of Evidence track. So just to remind you, what's our goal? So in the so meta-analysis is a way to synthesize the evidence. Basically, usually you have study from different research group on similar question, and the challenge is to basically how do we collect all those evidence and give us a final look of what's the real result would look like. And system review and the meta-analysis is listed as the highest level of the scientific evidence. And it's actually right above RCT. So usually when people need to make a decision about important thing, especially in like medicine or clinical field, they usually do huge meta-analysis on several RCTs and use that result as a reference for the final decision. And this is very important for the agent research as well, because usually you see those kind of small scale trial or animal study for a similar compound or similar intervention for agent-related outcome like lifespan. And usually they have a small sample size and also a slightly different condition, and also result also kind of scattered. So the question would be, how can we design a automatic platform to automatically synthesize all this information and give us our best analysis on what's the, for example, whether this intervention could really have effect on lifespan, and this will end many debates in aging field. So traditionally, this is of course done by human, and it's very require many manual work, and you need to first collect all the literature, and you need to assess the quality of literature, and then extract the statistics, and lastly, you will need to perform a statistical analysis to give the final result. So we have 3 teams actively working on this problem, and our criteria will be like it should be able to successfully generate a meta-analysis report based on the papers and prepare a nice report and give correct statistics. So our winning team is the Vitality Vanguard, and they provide a end-to-end protocol for start from the literature search and end with a very nice statistical report. And Alex will take from here to tell you more about their strategy.
Yeah, thank you, Albert. 1 second. Yeah, so the team successfully generated a meta-analysis for one of our tasks, and the results they got were statistically significant and similar to what the original paper showed. So we had a paper that a meta-analysis paper of effects of resveratrol on type 2 diabetes. and their AI agent successfully generated a report. So they implemented a search module that is looking for PubMed articles. Then it performs screening of RCT studies. And actually, in the original paper, there were like 32 or 34 papers, and they identified 30, which is not bad. And then they extracted the the data from these papers and conducted meta-analysis. And the values they received are quite similar, like within 5% error from the original values from the paper. So we also had a second test, but I guess they didn't have enough time to conduct the second test. It's for future work. And I think that it's a really good result that they received significant results which are similar to what was shown in the original papers. So the next step, I hope we will join our forces and we can improve it and publish a paper together. So I would actually invite other teams as well if they want to contribute, because their solutions were also pretty good and some of the ideas can be shared, because I saw some very good ideas from in other teams as well. And let me show you a just 3 minutes demo of the AI agent that the Vitality Vanguard made.
Hello, we are the Vitality Vanguard team, and we are presenting our solution to the Future of Evidence challenge. Our solution consists of multiple modules. You can run them in the pipeline.py file, or you can run them separately like this, because they are separate modules, and they can be, some of them can be more helpful than others and more polished than others. So the first module is protocol and PICO formulation. We start from a plain language question and structure it into PICO. From that we derive inclusion-exclusion criteria. The result is a formal protocol you can inspect and reuse here. Then we apply systematic search module. It searches sources like PubMed and PMC. We normalize metadata, resolve identifiers, and deduplicate across sources. So then we apply screening. We check full text eligibility and tag study design and data types. You can also inspect these files to check it. Then we have data extraction module. It parses raw PDFs with this library, and then we apply large language models to extract some key data from every paper. So this is, we apply the extraction schema in JSON. This reduce amount of hallucinations from the model, and you can see that this data can be gained from the papers. So then we apply, we are using our JSONs, raw JSONs, and we apply the meta analyzer module. So you can see it here. It analyzes and generate, well, it's quantify L squared and tau squared and generate forest plots. So you can see outputs with forest plots and results JSON and report MD.
Yes, and I would like to say that this team wasn't only the most efficient, has the most efficient solution. The price of one meta-analysis was only $3 and takes less than 10 minutes. So now from this we can improve, and hopefully it will be useful to everyone in the aging community and everyone else. Yep. Congratulations again.
Fantastic. Guys, that's really fantastic. I love this challenge and I love this solution. This is fantastic. And this is a future of meta-analysis.
Oh, warm words from Dmitry cost a lot. Thank you, guys. Thank you, Alex. Thank you, Albert. And we move on with our next part of our longevity hackathon. It's female longevity. And to start with, I want to introduce you, Laura, from VitaDAO. Laura, I hope you're here with us online to announce the winners of female longevity section. Go ahead, Laura.
Hi, everybody. I wanted to say congratulations to the organizing team. I'm sure you're going to have a great week resting next week, I hope. And also to all the teams that participated, at least on our challenge, I was very impressed about what they thought of, the execution, the thought process. And more importantly, I was excited about people thinking about ovarian aging and menopause. I know everybody hears about aging and longevity, but we always think it through this scope that is limited to our own cells, and usually it is male longevity. So I am there all the time, trying to remind everyone how important female longevity is because we're half of the world's population, because the ovary is a great model to study aging. So I'll encourage more people to use it. And the last thing is that we're very happy to be the place where anybody who's interested in longevity biotech comes and collaborates with us. Gero is a partner of us. Two of our science and DFlow members are at Retro.bio. We work with everyone and anyone who's interested in the science of ovarian aging. With that said, the challenge was executed so well by a couple of solo teams that we had to split it. So for the very first challenge, which I did not design, it was actually Rebecca Agamon who cannot make it because it is very late for her. She's a molecular biologist and one of our science and DioFlow team members, and she designed the menopause prediction challenge. I don't have a presentation like everybody else to go over it, but you can probably see it on the website when it's fully up and also watch the videos. We judged it. There were a couple of other judges, and we could not just pick one winner and we decided to divide the challenge in two parts. One was for the science and model, and the second one was for overall product delivery. So the two winners of the challenge are Fighting Aging, Alexeyev, who I barely had a proper time. We only managed to talk on TG, so congratulations, Alexei. And for the overall product is Vadika Goyal. I think I saw her here, and I just want to preface by saying to all the other teams that we were very impressed with all your work as well. I gave you my email. I want to continue the conversations with you. The two winners today win the ATH tokens as well as a potential grant for development or more research. So I'm very happy to be able to do this with you, hopefully in the future. And for all the other teams, we also want to continue the conversation. There was a lot there. We just had to pick a winner. And we had such a hard time picking a winner, we actually picked two. So I hope that these hackathons continue and I can get more technical teams and more scientists interested in the area of ovarian aging. Super important. I have a wager and I make it every time. We're going to figure out, the first thing we're going to figure out in reversing for longevity is probably going to be the ovaries. So whoever wants to take me up on that wager, happy to have a further discussion to put some money on it.
Thank you, Laura. Thank you. And to set you free, could I also ask you to announce the winner of the Blue Sky project sponsored by VitaDAO?
Oh, yes. The other project was the Blue Sky project, and we did have a winner. And it's, I don't have their, sorry, just let me get my note. I was so prepared for one prize that I forgot that I had to do the other one. The winner, drum roll, for the other prize is, oh my God, I can't find my notes.
I can help you because I know the name, but I'm sure.
Yes, help me with this to make it go faster. Please, Vita, announce the winner of the Blue Sky Prize.
The winner of Blue Sky Prize is Geo. I hope I pronounce it in appropriate way. Laura, can I ask you to explain briefly what was the idea of the Blue Sky and why you decided to give the prize to this lady? I think it's just one lady.
So the idea around this prize is trying for technical teams who are working with agents, with them, data scientists, and anybody interested in aging to think of what could be a solution in the space when it comes to ovarian aging. It was very open, not very defined. It was almost like, is there something you can come up with? And I think their solution was particularly interesting because it was thinking of uterine health in general, not just the ovarian health part, like ovarian aging part. And thinking of systems biology, the ovaries do not exist by themselves. Our health in general doesn't exist by one organ, right? We have to work in a systems biology way, and they try to tackle this from a different perspective. So that was the point. And we're very happy also to collaborate with them in further development and all the other teams. I gave everybody that I've met my email. I think VitaDAO is an open community. And we do like to collaborate because ovarian aging is massively overlooked, even though it's a massive opportunity. And we just have to do this all together. And thank you and congrats again to the team. Looking forward to doing more of these hackathons with you.
Thank you, Laura. Thank you. I know you was not up for some hackathons. Maybe we changed a bit your
Yes, hopefully we do. Yes, exactly. Now I'm into them.
Great. Thank you, Laura.
Thank you, everyone.
Thank you.
And congrats again.
Thanks. And now for the audience, I need to explain that we have three videos. Two videos from menopause prediction and one is for Blue Sky project, and we're gonna see only two. Alex, I'm sorry, but your video is opt out. So it's Vedika first, and let me share my screen to let you see what she proposed for us. Yeah. Edika, you are bio, just to be sure, you're bio4C, right?
What? Yeah, exactly.
Thank you. Share. Oh no, sorry.
I may not personally face menopause.
Sorry, guys.
Hey, I'm Vedika Goel, 21. I may not personally face menopause yet, but seeing my mother and aunt struggle with unpredictable symptoms like hot flashes, mood swings, and sleep issues made me realize women need better support. That's why I created Menobalance AI, a platform to predict and manage menopause symptoms, empowering women at every stage. Millions of women experience menopause symptoms that strike without warning: hot flashes, brain fog, and mood swings. Current healthcare only react after the symptoms appear. Women are left unprepared and unable to manage their journey proactively. We realized this gap and asked, how can we give women foresight, not just hindsight? Menopause affects sleep, health, productivity, and overall quality of life. There are very few tools to personalize guidance, leaving women and health experts unsure of the best decisions. This lack of support motivated us to build a solution that make a tangible difference. Menobalance AI predicts menopause symptoms using data-driven methods. We combine hormonal, lifestyle, wearable, and genetical data and give personalized real-time insights women get guidance they can choice, and health experts get actionable insights for better care. How it works? We built a simple, intuitive interface backed by a robust machine learning engine. Users fill interactive forms, access real-time dashboards, and interact with an AI-powered chat that provides empathic guidance. Our AI is accurate, supported, and privacy-first. Data-powered predictions. Our model harmonized 5 major datasets. They learn pattern across lifestyle, hormones, and wearable metric. For example, menopause stage classification with 99.2% accuracy. Now, let me tell you how I tackle this problem. As we know, we don't have a proper clear data set for this kind of a case. So what I did, I took the most largest data set available in the world. The first one was the NHA-NES, second was SWANS, third one was UKBB, fourth one was Cynthia, and fifth one was wearable devices data, which was also basically from NATS. I divided, firstly I combined all these data types, and then when I have the unified data set, then I divided them into 2 parts. One was for symptoms and second one was survival. So for survival, I focused on the features which devotes a lot on the onset value, how we will predict what is the onset value for menopause. And the symptoms one are the features which contribute more on the symptoms one. For example, the hot flashes, the sweats. So that's how I bifurcated, and I trained 2 different separate models on a separate data set on separate features so that I can predict both very well. Now, caring and intuitive platform. AI alone is not enough. Our platform is designed to be empathetic and easy to use. Women interact with a friendly chatbot. I have used Nebius.ai as model, and then with the help of that, we have created a friendly chatbot. We also track symptoms and visual dashboards and receive health advice tailored to their profile. Everything is secure, private, and intuitive. In speaking with gynecologists, I personally did with some, we learned that women often feel lost and unsure. There is a lot of gap in the awareness also. General advice isn't enough. They need personalized guidance. Our empathetic design addresses trust, clarity, and support every step of the way. The results are clear. Women gain foresight, confidence, and clarity. Health experts gain actionable insights. Our platform lays the foundation of global research on menopause, aiming to improve millions of lives. Next, we aim for a clinical validation through multi-site trials, integration with wearable for real-time tracking, and global accessibility with multilingual support. Special thanks to DAO, Nebius.ai, Open Longevity, and our mentor Rebecca for supporting this journey. Together, we can revolutionize menopause care. The next step, I want you to have a look on the demo or the website app that I have created with the help of the Streamlit. So in that, firstly, we have this privacy data protection. We just ask the users they are okay with that. This is just our homepage. From here also, you can just go wherever you want, and then I will just show you one by one. So this is the health input. Here, we take the information of the user. For example, right now I just have some sample values. You can here tell your age, your weight, your height, and it will automatically calculate your BMI. Then we have some hormones level. So here you can tell you maybe your FSH, and then the estradiol. I'm just putting some random figures. Then the AMH, and then okay, so it should not be greater than 20. So let's keep it 18. And then whatever you feel about your menstrual cycle, you can here tell your what are your lifestyle factors, what is your stress, how many times you do exercise, what are your sleep hours, what is your diet quality. If you have any medical history, you can tell if you want. That will definitely improve the predictions, and then you can just click on the get my predictions. On backend, we have our deployed model using using the fast API, and then you can see we have this. So menopause stage, perimenopause, time to menopause 9.6 years, severity 1.3 out of 10. That is pretty good. Now because I feel being a common man, it is very difficult to understand these complex things. So I just tried a lot as much I can visualize this. So you can see the confidence interval and the prediction. So here the probability is very high of this, and these are the time, and then these are the symptoms. As I told you, I have divided the classification or this prediction into 2 parts: survival and symptoms. So survival is basically for this one, the time to menopause, and then this is the symptoms, which we will predict the hot flashes, mood changes, and sleep disturbance. And then there are some personalized recommendations according to whatever results you have. So this is the thing. Then we can go to the wellness dashboard. Right now, I'm not storing the data anywhere because I just are made focused to predict the menopause. But on a long term, we can have a proper database where we can store all these data input by the the user, so that we can use that. like for the next predictions. So here you can just tell what is your sleep quality, stress level, activity level, mood, energy level, symptom severity, and that will just show. Like right now, it's just showing like the data is stored, but it will just store it. And then this is your wellness score, like according to today. So this is like today, according to whatever you feel. So this will tell you like how well you are today. And this PDF version of this is the ManoBalance AI. I have all these values, all the predictions. Now I can share these with like my doctor I can visit, and this is it. And these are the personalized predictions. So that's it from my side. If you have any questions, if you have any collaborations, if you want to collaborate, if you want me to collaborate with you, I'm open with everything. Thank you so much. Bye-bye.
Great. Thank you, Vedika. Thank you for this nice presentation. Too many reactions in our chat. I hope in San Francisco you also have a great support. And we move forward to see the Blue Sky project sponsored by VitaDAO. And I believe that you're gonna love the presentation, the demo that they have from this team, because it's quite nice. Just one sec. And I will share my screen. Yep. So this project was proposed by the team. We didn't shape it. We had no mentors except for Alex and some technical mentors, and they did it quite nice. Let's see.
Imagine you're a 26-year-old woman. You've missed your period again. You wake up tired even after 8 hours of sleep. Your skin has changed, your energy feels off. You've brushed it off as stress, but deep down, you know something's different. Your body has been keeping score in your glucose, your sleep, your cycle, but none of us can see these changes in real time. Here's where we introduce Aegis Cycle, the agentic AI designed to read your body's signals and help you preserve your reproductive longevity. Over the past 30 years, PCOS and endometriosis rates have doubled. The average reproductive lifespan has shortened by nearly 4 years. The system builds your reproductive longevity profile, showing how your metabolism, inflammation, and hormones are shaping your ovarian aging rate. Without early insight, symptoms pile up quietly. With Aegis Cycle, every cycle becomes smarter, guiding you toward longer, healthier ovarian function. Aegis Cycle's early detection engine achieved 90% accuracy for PCOS and 88% for endometriosis risk using everyday health data.
This is Aegis Cycle, agentic AI for reproductive longevity at any life stage. We turn cycle logs, Apple Health Seed, and simple labs into a clear risk with drivers and a 2 to 3 step weekly plan that adapts automatically. If you're in perimenopause or menopause, we track transition, protect bone health, and manage VMS and sleep with practical weekly actions. We explain HOMAIR, TGHDL, non-HDL, HSCRP, sleep efficiency in plain English, and map endo-flare patterns, pain timelines, cyclic GI urinary, HRV sleep dips into an easy summary for your clinician. Transition detection uses cycle variability, night temp spikes, and sleep fragmentation. Bone health adds protein and resistance training. VMS and sleep improves nights. The HRT navigator is education only, and red flags auto-generate a clinician path. Apple Health connects in one tap, and labs are drag and drop.
Here's the evidence we encode. PCOS carries higher cardiometabolic risk. Diet patterns like low GI, DASH, Mediterranean, higher protein consistently improve HOMAIR and lipids. Variables are data rich but insight poor. That's the gap Aegis Cycle closes. We run a closed loop. See, think, do, escalate. Live pipeline. I load a sample and run the analysis. The risk engine calculates PCOS risk and highlights drivers. Now, the personalized plan picks low risk levers, low GI dash, Mediterranean plus lower carb, higher protein, plus aerobic plus resistance and sleep hygiene if efficiency is low. Finally, the clinician escalation check applies conservative thresholds. If tripped, we generate a de-identified clinician path. Under the hood are 5 agents: ingestion, risk scoring, planner, coach, and clinician escalation. All actions are logged with a rational trace. Autonomy within guardrails. Lifestyle first, no dosing. Scheduled autonomy with an audit trail. Red flag thresholds for escalation and strict consent, de-identification, and data governance. The planner uses a bandit policy: select action, observe outcomes, and update. It balances exploration with adherence fatigue and never crosses safety boundaries. Developers can integrate via 3 endpoints: post risk score, plan generate, escalate check. The demo runs in mock mode unless an API is set. This makes the workflow reproducible and easy to extend.
This defines our total addressable market, a global opportunity worth $6 to $30 billion every year, within a $200 billion digital health ecosystem spanning telehealth and wearables. Our serviceable market focuses on digitally connected users, roughly 60 million people already engaging through existing telehealth platforms and wearable brands. That's a $1 to $6 billion reachable opportunity today. And with strategic integrations, even a small share, just 0.5% to 10%, converts to $15 to $300 million in annual revenue. Aegis Cycle isn't just tracking metrics, it's extending reproductive longevity, transforming women's health, and redefining how the world measures wellness. Aegis Cycle, Agentic AI for a longer, healthier reproductive life.
That's it. Thank you guys for your support. And let me make one step back to explain maybe you why we think that it's important issue of ovarian aging, of menopause prediction, and so on. And since we have no mentor to present it today for our next challenge called ovarian aging value, I would be the person who would announce you the winner. And I also want to thank here all the team of female real money. I'm sorry, girls, every time I need some time to pronounce it. Female Real Money Talks, who helped us a lot with this challenge and all the women track challenges. And you brought this on the table, and I do believe that without you, it was a different hackathon. And thank you so much. And thank Nick, who is now in National Park in America. So that's why he's not here, and I need to announce the winner. And the winner of Ovarian Aging Value Challenge is it is Optimal Rationalization Team. And guys, you're gonna have $2,500 by Life Ahead, sponsored by company, which is not frequent for our hackathon. And I'm very proud that Nick from Life Ahead did this challenge for us, and he was really very much interested in this challenge. So let's see what he
Can I just say something quickly
Sure,
about
sure.
Life Ahead so everybody knows? It's probably the only menopause prediction model that exists, real one. And super important, it just makes sense for them to be here. It is a scientific discovery by Dr. Joshua Johnson. So the reason I was very interested in Alex's model, though, because I think it's complementary to theirs. But for the context of who the sponsor of the challenge is and why Nick wanted to do it was because when you go speak to investors, they say that menopause is niche. So anyone working in the reproductive longevity field needs a tool that tells investors and clinicians and anybody who wants, who says this is not interesting, how much value there would be added to your portfolio, to the economy and to like GDP in general if we actually resolve menopause. Just that little side note. And it's obviously a Athena DAO supported company. So very proud that, you know, this is like a company that's now supporting other projects as well.
Oh, thank you, Laura. Very valuable comment. Yeah, thank you. And so optimal rationalization. Now it's your turn to present your final demo.
Is a $50.7 billion problem for 17.2 million women in the US, with a yearly cost of $429 million for 130,000 women. Every year, it costs more than 100 plus deaths, type 2 diabetes, cardiovascular diseases, and dozens of dimensions. Now let us tell you how we calculated it. Hi, my name is Mark.
And my name is Elias.
And this is our ovarian aging value submission. To make presentation easy to follow, we'll walk you through the steps that we did one by one, starting from scratch and ending with the final deliverable of the website.
I'm going to start by presenting you the agent. And first of all, what is actually the goal of our agent? The goal is to extract as many risk metrics as possible from scientific literature, so we don't have to scour through thousands of papers and find the data for the numbers that Mark just told by ourselves. I believe that the best way of showcasing this agent is by actually running it. So now, while I explain to you how this agent works, the agent is going to extract risk metrics. The first thing that the agent is going to do is that it's going to take the disease of interest that me as user I've specified, and it's going to create PubMed search queries based on that. Those search queries get then submitted to the PubMed API, and the agent gets back a huge pile of paper abstracts and other metadata. Then our agent goes through every single abstract one by one, deciding if the abstract is relevant or irrelevant for our disease of interest. For all the abstracts that are deemed relevant, the agent then tries to download the full text PDF. This works well for open access studies, but studies of closed access journals can't be accessed programmatically. So the agent creates a list of those studies that can't be accessed for us to manually download and then put in the pipe, so they are processed exactly the same as the automatically downloaded PDFs. Multiple Python libraries are then used to turn those PDFs into Markdown, and this Markdown is then fed into the LLM, so it can extract relevant metadata. Then the agent judges the quality and trustworthiness of each paper on the robust criteria by Whittings et al. 2016. Finally, the agent extracts the risk data, so the data that we were actually searching for from the full text Markdown. In our final run, this agent ran for 5 hours and 22 minutes nonstop, read through 1,655 papers and extracted 584 risk metrics. If you could read one whole paper every minute, reading all those papers would still take you more than 24 hours. This agent represents a 30 times speed up over a normal researcher's, and this is assuming that this researcher never sleeps. This is how the final result looks like, and I put the final CSV with all the 584 extracted risk metrics into our GitHub. I worked extremely hard to reduce hallucinations, so I dare you to click on any DOI in this CSV and check if the risk metrics are accurate, because I am convinced they are. We made all of our code and data open access under this repository, and there you can also find 2 videos. One where I walk through the whole code step by step, and the second one where I explain exactly how you can run this agent yourself. And now let's check what the agent extracted. As you can see here, the agent checked 42 metrics and found 23 interactions. Here in the terminal output, you can see exactly what the agent did, and this is the CSV that was created.
Now onto health methodology. There are 4 parts to it. First, choosing the risk values out of those 500 that Elias has provided us, mostly done manually, and making sure that the cohort constraints make sense, and the study quality is, of course, high, based on robust. And step number 2, finding annual incidence per 100,000 people for each of those diseases. 3, apply those to values and find the net effect. And 4, scale to yearly and US in total. Here, I created a table that briefly summarizes some of our findings. Some of this data is more straightforward than others. So for instance, risk value is obvious, getting the net effect is obvious. Why do we scale to 130,000 people? This is because this is the number of women that enter menopause before 45 in the US. And we'll make sure that our data represents the reality. Now let's talk about economic methodology. Once again, there are 4 parts to it. The first part is finding the annual direct cost per incident. And once again, it's more of a witchcraft than science, but you always want to go for the best proxies, and we document that directly in our report. Second, we want to find also indirect costs. So if direct cost is something like medicaments and direct medical bills, indirect cost would be the loss of productivity, absenteeism, presenteeism. Then we take the net effect for 130,000 women, and we multiply them by the annual direct and indirect cost to get the yearly cost, and you can perceive it as the yearly addressable market. What is important is you have to take those costs then and scale them to 5 years, because this is a 5-year menopause delay, and we apply the present value for that. And lastly, you can scale that data to US in total, which is 17.2 million women altogether, and you can perceive that as total addressable market in US. Now let's talk a bit more specifics. Once again, we go in more detail for the report, but I just want to highlight one part, let's say, of all-cause mortality. What would be a direct cost of a dead man? There are no costs that apply to a dead man. That means we need to create a proxy for it. One useful proxy we found is the yearly cost in the last year of one's life. Then we want to calculate the yearly cost to 130,000 people. And then for this table, we take and scale our data to the 5 years and apply the present value of 3%. In general, there are 3 useful links for this project. First, the report with all our assumptions, sourcing, and exact values. Second, the code report that Elias talked about. And third, we proudly host menopauselater.com for our website as a final deliverable. The main idea is to tell a story. What is the problem that we're trying to solve? An instant impact that one can see, spreading the word about the information. And as the last word, we want to say thank you to Alexei, Nick, and Michael.
And we hope to see you next year.
Great, guys. Thank you. I see that Mark.
Представьте, что вы случайно наткнулись на сценарий короткометражного фильма, который описывает сцену между человеком и ОИИ-ассистентом. В сценарии есть то, что человек спрашивает у ИИ, но ответ ИИ оборван. Предположим, что у вас тоже есть...
Sorry, we have a little bit of a technical issue. Mark, congrats on winning this track. I will take it from there while Vita is solving technical issues. So I believe the next is actually Andrew
Yes, sorry.
Tarkov. Andrew Tarkov, are you there physically from Retro.bio? Please get the mic.
And please, Andrei, be a mentor and a sponsor as well, because Retro.bio supported the second hackathon this time, the second in a row. And thank you for your support. So we're very pleased to give you this scene and mic to present a bit retro for people who doesn't know.
Thank you.
Yeah, it
Thank you
means
for
a lot.
organizing.
Thanks a lot, VitaDAO, for sponsorship. This is huge, and Retro as well. Andrew, welcome.
Thank you, Alex. We provided a task, like we asked the to solve one of the issues that researchers face in the protein engineering space. So we have proteins, we want to change them, but we need to know how. We need to like what people have already tried before and like what functional outcome it led to. So we asked the our contestants to create a tool for people to basically like insert their favorite gene and learn as much as they can about what people have tried to change in that gene and like to what functional outcomes it led. It was a very tough competition. We had like eight submissions, and all of them are very good. It was very hard to find like one winner. So in the end, we had like we defined like 3 best, I would say, best solutions, even though it's very hard to like pick one of them. And others are not bad at all. It's just like they're lagging in some like technical aspects, or maybe in their like, like API. So just like hard to test them. And also to balance it and to solve aging, we need to, we need wet lab people, AI scientists, and just like scientists working together. So we kind of implicitly were filtering for solutions that were accessible to everyone, every researcher, by, picking our jury. On our jury, we had like 3 people, a wet lab team, a lead AI and aging person. So basically I had like 3 people with completely different backgrounds. And it was like, they were like 3 checkpoints for every solution submitted. So, okay. In the end, we challenged our 3 top solutions to give us a bit more insight into like into their tool, because they had basically like, they were scored the same, but they had different advantages and like disadvantages of their approach. Some of them would go too broad, and they would basically copy some like UniProt and like aggregate multiple databases. But you would be able to basically query that database immediately and get an answer for any gene. Others would go very deep into like one gene And basically, they would provide a very extensive report that's super useful for scientists working on that specific gene, but it wouldn't be able, like we couldn't really test it. So basically, we send them 4 genes and asked them to provide reports for all 4 of those genes, which were not mentioned on the website or like in the original formulation of the problem. So it was like a challenge for them to test if they actually, we as a user can ask them to provide like, some answer within like 1 or 2 hours. And I guess like unfortunately, they couldn't do that. So we decided to basically split the price across the top three solutions. And let me start with like West Coast vectors. They focused on a class of proteins and actually did a great job finding sequence to function relationship for that class of proteins. I think it's chemokine receptors. And unfortunately, their website is not queryable, so we cannot like test other genes to check if like their solution is actually generalizable to other proteins. But it's great. I mean, they actually did a great job, and we're going to show their video later. The second, it's not the second, like the second team, not the second like ranked team, is Immortal Combat. They have a very general tool that basically you can use it right now. You just insert the gene and it provides a very great overview of its sequence function, like context in the context of aging, with all the references provided. It's already kind of very useful tool which you can use. And the third one is Longevity Genie. They don't have a public API or website. They have like an MCP, basically like a plugin on top of your Claude app that would also do quite a nice job in like summarizing all the data for your gene of interest. And I guess I would like to distinguish another group here. It is just like, it's called Sapiens. They didn't actually provide a solution to the original problem. They didn't do sequence to function, but their search tool is great. Basically, you just like insert a gene and then like you get like 20 papers summarized and parsed, which may be useful as well. So thank you, the teams. And I guess like Vita, can you show the video of West Coast vectors?
Yes, yes, I will. Thank you, Andrei. Do you want to add anything else from Retro.bio side?
It's a good question. I guess like in general, all those solutions are useful, and we would encourage people like all those teams to maybe collaborate and like copy or like share their best parts of their solutions, and like maybe like even like merge it into one tool, one API, one database that people could use, and I think it would like speed up the progress in the field a lot. So yeah, good luck to you, like all 8 teams. Thank you for your time.
Thank you, Andrei. Thank you, Retro. And let's go ahead. So again, this is not the only one winner. This is one of the winner that we and Andrew suggested me to show their video because I believe they have the best demo. So let's enjoy.
Hello, my name is Ryan, and I'm going to talk to you today about our hackathon project, AI-powered sequence to function Wikipedia for longevity research. This is our submission. Our team is West Coast Vectors. That's Felix, Matthew, Zach, and myself. All right, let's get started. So what's the problem? Critical knowledge is trapped in unstructured text. Vast amounts of proteins, sequence to function data, vital for longevity research is buried in millions of scientific papers. Manual extraction is slow, expensive, and unscalable. This bottleneck hinders discovery of new therapeutic targets and the design of interventions. Our solution is an AI pipeline to automate knowledge extraction and synthesis. We built an automated RAG system that reads papers, extracts key sequence function relationships for the CC chemokine receptor family. The pipeline creates a queryable face vector store linking protein variants domains to phenotypic outcomes related to inflammation. The pipeline finally synthesizes structured Wikipedia-style summary articles for researchers to access via a Next.js website. Technical architecture has two phases. There's an offline pipeline that builds a knowledge base and articles in Face, and then an online serving system that serves those articles to the website. The backend pipeline has several key stages. Data is fetched from structural databases such as Uniprot, and the full text and abstract data is then extracted from Europe PMC. And then we're saving the paper text and metadata locally as JSON files. And then we're doing the indexing and embedding process, converting those papers into manageable chunks with Llama Index, and then using Nebius to generate semantic vector embeddings for each chunk. Then storing those embeddings and text in a searchable local face vector database. And then doing the knowledge extracting, retrieving the most relevant, say top K text chunks from face based on a protein query, and then using Nebius LLM with a scientist persona to extract relevant structured facts as JSON from the retrieved text. And finally, another Nebius call with a writer persona to take those facts and write the web page. Yeah, we can have a quick demo. So the backend fast API, we can just look at quickly here. Here's an example endpoint where you query with a protein name and some of the data scraping is performed. So that gives you a flavor of that. And then yes, the final website articles. So here is the APOE article. You have the amino acid sequence structure preview, which looks nice. And then here's the data that was gathered. So for APOE, we have an overview. We have a sequence to function table with the interval, modification, function effect, longevity effect, evidence, and citation. So here we have several results for APOE, and then some notes at the bottom about APOE, giving some more details. And then finally, here's the CCR1 article as well, similar in structure, pulling multiple citations that are longevity relevant for this particular protein. Okay, and so that's the demo. And then challenges, yeah, so the embedding vectors was slow and time consuming. There's challenges with extraction accuracy with the manuscript data. And yeah, we'd love to, in the future, expand coverage to all kinds of longevity-related protein targets, integrate fast API with LangChain potentially, and deploy the face database and API into some cloud server for scalability. Here's our tech stack that we used. And yeah, conclusion. So we built an automated pipeline using fast API face and Nebius to unlock sequence to function knowledge for the CC chemokine receptor family. And this is accelerating longevity research on inflammation, providing reusable framework for automated knowledge extraction. So please visit our live demo and check out our GitHub repository. Thank you so much for your time.
I have a lot of strange videos from YouTube. Sorry, guys. Thank you again, Retro.bio. Thank you. The teams participated in this challenge. Actually, I think it was one of the most popular challenge. Yeah, the most popular challenge. They had 9 or 10 submission, so more teams participating. Not everyone submitted, unfortunately. But this is the time to continue. And now I'm honored to present you the next challenge, which was daily prediction. Daily is the destroyer. Yeah, Alex, what do you
I
want?
think it's disability adjusted life years.
Yeah, sorry. Could you, okay. So my idea was that this is on the contrast, it was the less participated challenge. So we had only 2 teams, but the one team definitely did the great job. And now we want to say that, guys, I'm sorry, the name of your team is something that I need to take a minute to pronounce. So it is Heterocephalus glaber. I hope I pronounce it correct. And yeah, since Alex from Axiom is here, I would love just to tell you that we are very pleased that you participated in this challenge, because we selected this challenge because we believe that maybe this is one of the most crucial thing important for clinical trials, and we do want people to make more to pay more attention on this field, and we are very pleased that you participated here and suggested some kind of the decision for the problem. So for now, let me just show your Loom video.
Hi, my name.
Just a second. I think the team members are here, right? So guys, wave a hand if you are here with us in Zoom.
Hello.
Congratulations, your team won, and this is your...
Hi there. Yeah, Heterocephalus is the name for the famous snake mole rat, which is famous in longevity field.
So let's see.
Name is Tim, and in our challenge, drug-induced liver toxicity prediction, we had to predict toxic, non-toxic target, a metric AUC, from smiles of some drug and its dosage. Our approach at a glance is to enrich the dataset with bioinformatics APIs, internet, and AI, then train classical ML classification models from scratch, and also we tried specialized smiles models fine-tuning, and then construct combined inference pipeline, including reasoning LLM on all the data we collected and our ML model. So our objective, firstly, is to collect more high-quality data. We selected Inch as unique key, and then gathered all the known drugs from Campbell, 11K rows. We collected various data probably related to hepatotoxicity on these drugs using clinical trials API, also sonar-grounded LLM by Perplexity, which searches everything which is relevant in the internet. And then we also cleaned DLRank 2.0. We enriched it with smiles, generated clear labels. We also tried NCBI API, but it was not stable. So our Perplexity agent, firstly, we subsetted drugs to reduce the labeling time and cost. We utilized bioinformatics for it. We clustered molecules into groups based on scaffold similarity. And then in each cluster, we selected about 15 compounds to research using max-min diversity picking. And then we used Sonar with academic filter. As a result, we got more than 4K molecules with 500 toxic molecules among them. We verified this Perplexity agent on some small subset. It works well, especially on DLRank. So it actually finds the relevant info, even if we filter search so that we do not see DLRank itself in the results by date. Clinical trial APIs also work, not always, but generally it's okay. So what is our reasoning pipeline? We collect up to 20 clinical trials summarized by GPT-5 Nano, combined with Solar academic research, and then we feed it into GPT-5 mini reasoner, which outputs toxic, non-toxic label, but also minimal toxic dosage, which is very useful, brief text rationale about it, and confidence level. We optimized our reasoning pipeline. We calculated parameters for parallel execution to fit into OpenAI's rate limits. Here are some details. We validated it on very small subset, but it works quite well. So it's possible to perform zero-shot predictions on any known molecules with our pipeline. Unfortunately, we didn't have enough time and OpenAI credits to assemble the data set with this cool pipeline, but we would be happy to continue this project. So talking about machine learning, our best combined model, which combines dosage and smiles as input, is CardBoost, trained on our enriched data set. AUC is 0.851. And the toxicity is actually a very important feature here. Also, we trained some fundamental models from smiles only. It turned out that transformer on smiles is the best. AUC is about 0.79. So we fine-tuned it and increased AUC to 0.85. We also tried to train dosage-aware calibrators on top of fundamental models. But it turns out it's not really a good approach. So for perfect dosage handling, we just need a data set with minimal toxic dose, which we can produce using our reasoning pipeline. So here is the summary of our final pipeline. We fix smiles. We try to find some relevant data. If our reasoning LLM are not sure or there is no the information, we just return machine learning generated score. Here are our main results.
Great, thank you guys, and thank you for the nicked Molred. This is the Latin word that I cannot pronounce. So congratulations, and let's move forward. No, before we move forward, I need to tell you that Alex told me that he is extremely impressed how much work you did during this 2 weeks. So it's really impressive. Thank you. And we move forward with Vlad from BIO.XYZ, and I would give him a turn. And I love Vlad not only because we all love BIO.XYZ, but also I love that Vlad told me that he was really impressed by the work of our teams. And it actually warmed my heart. Thank you, Vlad. Please share it. Tell them the same words that you told me.
Yeah, sure. Hi, everybody. Yeah, sure. Can put here. All right, do you hear me? Okay. Hi, everybody. I'm from BIO.XYZ, and we set a problem for this hackathon to predict a clinical trial outcome. Typically, clinical trial outcomes are predicted as for the whole clinical trial, but we split the data to endpoints. And a few words about the data. So we collected ASCO conference clinical trial release data from this year. Basically, it was about 6,000 original abstracts that we parsed, and we filtered them with OpenAI Deep Research to make sure that any single endpoint in the trials didn't appear anywhere in the past from in different other sources, and to make sure that we actually will be able to create a proper benchmark so that teams can participate and build agents, that we can test and be sure that they actually work. So we split the data set and made the test set balanced and created a Kaggle competition for this challenge. And we got 5 teams, and I was impressed how high quality, what level of accuracy we can actually achieve on this problem. So I would like to speak about the first solution and the second one. So we got we actually got 3 great solutions, but I will only talk about the 2 ones, the very top 2 solutions, because these are actual winners. So the first team, it's Isida, Rakesh came out with an approach of multi-agentic LLM system that is built on with Crew.ai, and it has 5 agents. One of the agents is searching for the information. Another agent is biostatistician, and all other sub-agents doing different work in different subdomains. But the thing is, he created amazing prompts because he ingested the biostatistics from the historical data on clinical trials, and that made the solution actually working pretty well. So we asked the teams to make agents such that they will not be able to easily, get information from the web after the Ask a Conference, because after the Ask a Conference, we see a lot of results actually published in the news because everybody's waiting for clinical trials, and yet the teams, the 2 most performing teams, actually filtered the web search pretty well. And most importantly, the number 1 solution, which I liked, it was actually made, the guy hacked LLMs, I would say, because he wipe coded a lot. Claudio was his programming partner, but he came up with the best solution, actually, 78% accuracy on the Kaggle leaderboard. That is number 1. And yet it shows us that the baseline actually is pretty strong. We could not break the solution. We could not find any data leakage in his predictions, which is pretty great. This is what we actually expected to see. And I will talk about the second submission. The second submission was built by Andrew Elashkin, who also built a multi-agentic system, this time with long graph and long chain stack. And he made lots of tracing with Longsmith and all kind of things, so that we can actually see how the agent performs. He had the most, clean red-green flags of every clinical trial, outcome reasoning by an agent. This is actually the important piece, because we need to have interpretable results, not only just the score of the prediction. And he did this a great job, but his drawback was that his web search actually was leaking to some of the existing data published after Ask a Conference. So it's a little bit of data leakage there, and but still the solution is great. And also would like to select this participant as a winner. So, and now I think we're gonna watch one of the videos of actually the top 1 solution. And yeah, I'm glad that we are at this point and we have a great baseline for our problem.
Thank you, Vlad. Thank you. Congratulations to the winners, 2 winners, EasyDAO and Peak. And we're gonna watch now the EasyDAO solution.
Welcome to Aquaware, hybrid AI for clinical trial outcome prediction. We are accelerating cures through trusted AI. I'm Rakesh Luthra from Team EasyDAO. Every clinical trial is a race against time. Did you know that 90% of clinical trials fail to meet their primary endpoint? The average cost per successful drug is $2.6 billion. Can we predict endpoint success earlier? This mission is inspired by my personal journey. Earlier this year, my sister was diagnosed with stage 4 bile duct cancer with the IDH1 biomarker. A drug took years to develop and was hard to access. I often wondered if faster diagnosis or research would have changed her odds. That's what drove me to build Aquaware, making predictive, data-driven clinical insights available faster and more fairly. Clinical trials are complex and unpredictable. Human experts can't process existing trial data, and prediction models often leak data or overfit. Research cycles remain long and costly. The central question: will the endpoint be met or fail? Why does this matter? Earlier decisions can save over $100 million per trial. Better trial design leads to higher success rates, and faster drug development helps patients sooner. Aquaware achieves faster drug development and higher clinical success rates through advanced, trusted AI. Traditional approaches often fail. Pure machine learning lacks enough training data. Pure LLMs suffer from publication bias and ignore historical patterns. Hybrid systems like Aquaware combine both strengths: reasoning, evidence, insights. Aquaware unites expert-style reasoning with data-driven evidence. It thinks like a doctor and learns like a data scientist. How does Aquaware work? We use 5 LLM agents: a data analyst, biostatistician, safety officer, risk assessor, and a chief medical officer. Our architecture is a 4-layer system. First, a multi-agent LLM system. Second, machine learning feature extraction from historical patterns. Third, biomarker tier classification. And fourth, calibration to clinical reality. The input starts with the trial data and context, processed by 5 LLM agents and multiple layers of cache. The multi-agent LLM system, including specialized agents, data analyst for literature research, biostatistician for sample size, safety officer for adverse events, risk assessor for design risks, and chief medical officer for final synthesis. Layer 2, machine learning calibration, uses historical base rates. The overall clinical trial success rate is 78.3%, but rates vary significantly by phase and endpoint. Layer 3, the biomarker tier system. There are 4 tiers, from FDA-approved biomarker to experimental. For example, tier 1 biomarkers like PD-L1 and HER2 reach almost 90% success rates, while experimental markers are below 40%. Layer 4, clinical reality calibration. Aquaware applies realistic base rates and penalty adjustment to account for trial design, rarity, and endpoint type. Adaptive thresholds and chief medical officer oversight ensures prediction reflect real-world outcomes. Survival endpoints require sufficient events. Penalties are applied based on trial phase, population size, and rarity, ensuring the model doesn't overestimate. Using our prediction flow, users submit trial data for analysis. LLM agents and ML features classify biomarkers and calibrate predictions for reliability and detailed reasoning. Interpretability is key. Aquaware offers triple-layer transparency, including full agent conversation traces, feature importance breakdown, and penalty application percentages. Our system is transparent, auditable, and reproducible. We comply with all competition and validation rules, leveraging a time cutoff to prevent data leakage and confirm provenance. Our hybrid system consistently outperforms baselines thanks to our innovative architecture. What makes this system unique? The hybrid architecture, explainable and leak-free validation, and hybrid confidence metrics. Acquire was developed by Team EasyDo for Agentic.ai Trial Outcome Challenge in 2025. Thank you very much for this opportunity.
Congratulations. Thanks a lot for participating. Now I usurp the mic because it is time to switch back to rapid adoption track. And Vita, 10 or 20 minutes later, said that Retro was the most popular track, but it is not completely true. Rapid adoption saw more than 20 submissions. So technically, it is the most popular track. So it was heavily focused on entrepreneurship. So I'm quite happy that a lot of people still choose this route. So I had a very great time, even though I had several sleepless nights. And we have been selecting the winners. And we have 2 winners for this track. In addition to what VitaDAO already provided and what Nibios already provided, we also give 2 prizes. And the first prize goes to the team by the name of R Solo. Congratulations, Rahan and Daniel, who is hopefully in the audience. Daniel, if you are in the audience, please stand up and show yourself. Yeah, I know this team quite well. You did brilliant work. And another team member is Bob Walsh. So they're focused on extracellular matrix. This is kind of area which is unfortunately not many people are working in, but I think this particular project can do a lot to accelerate it, and all the judges agreed with me. So let's share the video.
Our project, we built ECM Aging Atlas. It's a database of time-resolved proteomic signatures that look into how the extracellular matrix changes with age on a protein level. The rationale for that is as follows. Biology relies on a collection of first principles like Mendel's laws, evolution theory, cell theory. However, these principles, they describe processes that take place inside cells. However, outside the cells, there's this complex substance called the extracellular matrix. Back in the early microscopy days, it was believed that it's just an inner substance that provides anchoring support. Now we know that it's an extremely complex substance that comprises more than 1,000 different proteins that dynamically change in response to age and pathology. Working with proteomic data sets is difficult because proteomics data are non-uniform due to difference in sample preparation workflows, difference in quantification methodologies, etc. And all these nuances make direct comparison between studies difficult. So we have come up with a data ingestion agent. So it's an agent that takes in all those different data sets, brings them to a standardized schema, normalizes the values, and applies batch corrections so that the data from different studies can be compared to each other reliably. And we compiled our data into a database for unbiased comparison between studies and different compartments with tissue and organ level granularity. So currently our database is live at this URL, and I will be walking you through some main features of the database. Okay, here's our database. It has three main tabs. One is all about the database itself, how it was compiled. Data can be looked at individually in a dedicated tab, so different data sets, for example, for the heart. Okay, we can see abundances represented as heat maps comparing young and old organisms. And if you scroll down, there's all kinds of different visualizations. To compare data sets, you go to a separate tab, and then you can select the organs that you are interested in, for example, kidneys and lungs and ovaries. Then look only at upregulated proteins, and then you apply filters. Okay, now you see the output, which you can sort by magnitude or by category. So yeah, quite useful. In addition to the visual inspection of matrisomic changes that the database offers, we believe that our data is extremely useful for novel hypothesis generation. To test that, we used 10 parallel agent pairs to come up with novel, exciting hypotheses regarding aging biology. And yeah, we have been able to generate quite exciting ideas. And to validate the hypothesis, we again used agentic pairs to run independent parallel verifications, then synthesize their findings, and on top of their report to generate next three new hypotheses. And thus we created this flywheel of innovation. Yeah, so the database is quite useful for anyone interested in matrix biology and anyone who wants to generate new ideas, new working directions. And we're three people, and we've been happy to present the results of our work. And thank you very much. See you soon.
Congratulations. Great work, Rahan, Daniel, and Bob. Really impressive. And I hope we really discover new opportunities in extracellular matrix, and it will help us live longer. The second winner was very hard to choose. Two companies, proto companies, teams came very, very close. So I could not really make a decision between them. Then it is now a great time to actually remember who sponsored our track. And I want to show a big, big appreciation to BIO.XYZ, the launchpad for biotech projects and AI agents focused on biology. Please consider launching your agents there. Great support from them. And VitaDAO. And when I looked what their marks are, they had a slight lead. They gave a small advantage to Longevity Pro hackers. JP, congratulations. And another team member who won. I know that JP is on the call. Huge congrats, man. Great work. So let's see what they have here for us.
JP with the Hi, I'm JP with the Longevity Pro Hackers group, and this is our submission for the hackathon. This is for the rapid adoption track. It's the Longevity Interventions Evidence Database tracker. And the problem that we're trying to solve here is that, as you're probably aware, there's a fairly big misinformation crisis in the scientific space and the longevity space specifically, where people are following influencers who are giving information that they're not backing up with real data and science, or they're using unproven interventions and supplements. And even if they are trying to be responsible and do their own research, there's just too much data out there for them to parse. 18,000 results here for longevity therapy. Trying to synthesize this many studies is next to impossible for any individual. And we know this is true because over the years writing for longevity advice, I verified this with hundreds of individuals, readers, biohackers, researchers through studies and conversations. So here's one survey that we did, and you can see here the plurality of people are saying that the reasons that they haven't invested more in their own longevity are things like they don't know if a certain intervention or supplement will work. They don't know whose recommendations to trust. They don't even know where to start. They're totally overwhelmed. There's so much information out there. So our solution for this is this longevity interventions database. And we've built now kind of three big components or legs to that. The first is an edge function that automatically monitors PubMed for new longevity research. And it has a Perplexity integration that will extract that evidence and put it into the database. We've also now built an evidence judge agent that will verify that information that Perplexity is pulling, things like dosage, side effects, lifespan extension numbers, that sort of thing. And then finally, we've added a chat assistant for users to ask questions and get answers directly from the database about specific interventions. And so here's kind of how that works. So you can see here, here's our PubMed edge function. It then pulls studies in to be reviewed. Right now, it's by a human. We eventually hope to automate this fully. We can then, create a new intervention if we don't already have dietary citrate, or if we do, we can link it to an existing intervention here. And then as soon as we hit link study or save intervention, that will go ahead and automatically analyze the studies, as I said, with Perplexity, pull that information out, and kind of display that here. So you can see, dosages, lifespan extension, human versus animal studies, it's kind of showing which biomarkers were tested in the studies. And then we're linking those studies directly as well. And then on the kind of other user interface side, so the chat interface here, so we've got a couple agents. So we have the main live chat agent. You can see here the user asking about metformin dose. So it's then going into the database and checking dosages that are being reported in those studies that we've pulled into the database. But it's also got some guardrails in that it's saying, there is not an exact optimal dose for longevity. This should only be done under medical supervision, et cetera. And then it's kind of linking to the individual intervention page as well for people to check themselves. And then, as I mentioned before, it's able to call up directly to the judge agent if it needs additional verification of specific things. So here we're asking it to kind of verify and confirm some statements that it's made. So it calls up to the judge agent, which then uses its tools to research and kind of look at things. And as you can kind of see, here's our agent trace. So the master agent's calling up to the judge, which is then using its tools to verify this information, sending that back to the master agent, which then will display that for the user here in the answer. So our main goal here is social impact. We want this to be a free tool to help researchers, to help individuals. We've already got interest from the International Longevity Association and investor Carl Flegger, whose list of longevity therapeutics has actually formed the basis for our database currently. So there you go. That is the Longevity Pro Hackers project. Here's links to the database, chat interface, and our GitHubs. And please do contact us if you have questions. Thank you.
Yeah, congrats, JP. Very happy for you. And JP is such a strong person that their team actually won 2 prizes today. Nibius also gave them the second or the first prize. So this was the second prize they got today. Yeah, what a team. Right now, I want to actually remember that we have another wonderful sponsor, Immortal Dragons. I believe Isaac is on the call, so I want like a couple of words about Immortal Dragons and your special prize for Rapid Adoption track. Who you might have chosen? Isaac, are you here?
Hey guys, I'm here all alone, and very nice to meet everyone. Yeah, so let me get started. First of all, my name is Isaac. Due to the time zones difference, most of our team members are right now working on Asian time, so it's their midnight. So I'm representing Mortal Dragons and announcing our pick for the winner of our tracks. So first, I want to thanks to Alexis and Vita for putting up such great hackathons, and very happy to meet all the people here. Without further ado, I'll try to keep it short. Our special prize sponsored by Mortal Dragons goes to OMIC.OS. And forgive me, there's a very hard time for us to choose the winner since we can only pick one. And we really like to work with the rest of the team in our tracks for further developments, for idea exchange, and for future plans, exchange and talks. So please reach out to us. You know how to do so. We have a website. It's called id.life. Right? You go to id.life, there's contact informations. And so reason why we picked OMIC.OS. So our 2 cents is that multi-omic testings are very crucial and to diagnostics and treatments. However, it's very costly and it's immature. The technology is immature at the moment. And due to many reasons, actually, lack of data is high cost, lack of standards and computational powers, you name it, right? We think that OMIC.OS is a team that's working on a team of brilliant people that's working on brilliant problems, very important problems. And this type of team is what Immortal Dragons usually go above and beyond to support, right? So since we're here, let me just reiterate about Immortal Dragons so that everyone knows what we're doing. We're a longevity fund based in Singapore. We support radical life extension projects like whole body replacements, like artificial wombs, 3D biofabrications, all kinds of radical interventions that are typically under-supported by traditional ventures. Right, so we think that multi-omic testings are a very important aspects that could bring great impact to the society, so as all the other aspects that we support, artificial worms, and those that seems impossible, that brings less financial returns and high social impact if they succeed. That's the directions that we're going to support. Our portfolio is pretty self-explanatory. Why is that? We're a single LP structure with no LP mandates. So with that being said, we're basically able to do whatever we want with our funds, with making flexible decisions, fast decisions, supporting projects that allow us to set the financial side of things aside and focus more on the impact, right? So if you have moonshot ideas, all the contestants, competitors in our tracks, if you have great ideas, please come talk to us. Send us an email via contact@id.life. We'll set a meeting, we'll discuss, and we'll go from there. All right, I won't take too much of everybody's time. Again, thank you, everyone. Thank you, Alexis and Vita.
Thanks, Isaac. Wonderful fund. We need more funds like you. Plain and simple. Okay, Shahryar, congratulations. Now I'm gonna show your submission. Great work as well.
Thank you. Yeah, I enjoyed the talk. Thank you.
Hello, Hackathonians. I am Shahryar Shahini, PhD candidate in the Department of Chemical and Biological Engineering at UB. I am joined by Kevin Saleh, a senior software engineer that builds fantastic user experiences and automated workflows. The problem is that omic technologies generate massive data volumes, and there is a lack of a standardization that makes it difficult to reproduce or compare results across different studies. Data interpretation is time-consuming and difficult, and the progress of biotech lags despite the tech advances. Our vision is a world without sickness and decline, where personalized medicine eliminates aging and diseases before symptoms appear. Researchers can upload any omics data for analysis. All the omics data are automatically analyzed simultaneously and combined to generate a holistic view of the biological system. This will make sophisticated omics insight available to all researchers. And this would transform data into clear, concise insights to accelerate drug discovery and patient care. Our solution is the automation of this process, where machine learning processes large datasets and standardizes workflows. This would allow instant exploration of findings. AI assists in understanding complex biological findings, and it suggests interventions for researchers to take advantage of.
If you go to the methodology page, there's a bit more information about the full analysis pipeline that we run. It was run across 3 datasets, so not all have the same steps. And it's Python scripts, and the process is still somewhat manual to get it done for any dataset. It takes about 30 minutes to an hour to run for a new dataset that is similar to the ones tested. But some steps are really common. Like the first one is to process the data and quality control to normalize and standardize it. Then there's UMAP clustering and characterization of clusters and selection for deep analysis. Then we validate the clusters with some stability validation, and one of the most important steps is to build this network analysis, so we can build a network of the different genes that is helpful to navigate from gene to gene. Then there's a few other steps that allow us to characterize the genes, to find pathways and go terms, and other steps that allow us to score the genes. For different datasets, there are different ML analysis that can be run. In this one in particular, since it was temporal dose based, we also ran temporal dose response analysis, responder analysis, and gene type classification.
Here I am going to give you a live view of our project. On this page, we have the type of the project, which has like 15 samples with different time points, and it includes young and senescent cells and also nano treatment or partial reprogramming. Kevin have made this amazing chatbot on the overview page, and you can ask anything from the chatbot. The example here is that which biological processes are changed with senescent and what is reversed with nano. AI suggests cluster 7, which is senescence markers like CDKM1A or P21. On the gene page, there is a functional network graph that you can interact with it, and you can click on any genes on the graph and go to that genes page, read the graph again to interact with other genes that are associated with that particular gene. You can see the network connections, and as you can see, PLK4 is connected with that gene. If I click on this gene, I can go to that page. Kevin has developed this fantastic AI synthesis writer. This AI integrates user input data and analysis with extensive literature search, and provides a detailed report based on the data and suggests interventions. So for example, here I asked how is this gene affected by NANOG and what are the other genes upstream that affect this gene. I just put the user-specific question answers. So this is giving me some idea of what is happening, like P53 pathway and DNA damage response. And also it shows me that is the top co-expressed gene, which is oxidative stress response. The social impact of this platform is that it converts the week-long analysis bottleneck into instant actionable insights. This would remove the bioinformatics barrier and empower the hundreds of non-computational labs to enter the R&D space easily. This would increase the chance of breakthroughs significantly. This platform can be used with any other diseases or treatments. For commercialization of this platform, we have solved a problem that biotech is facing, and that is large costs and large waiting times due to outsourced bioinformatics labor. We propose immediate standardized multi-omic analysis at a very competitive price. I hope you enjoyed this platform as much as we did. I want to thank Kevin for all his time and effort to make this happen. Looking forward to your feedback.
Yeah, thanks a lot. Congratulations. That is unfortunately it for today's part of the rapid adoption track, but we only are beginning. So we will support most of the winners and most of the projects who participated to build it further. So please stay in touch. We'll have some news and introductions next week. So yeah, Vita.
Thank you, guys. I'm sorry. I just need to tell you that it's really impressive. I saw how much work, how much effort, how many efforts you did during this almost 2.5 weeks, and it was like all the sides worked, mentors, sponsors, organizers, and of course participants. And it was extremely important for us to see this change of the energy between the different spots all over the world. And we know that people in India, in Malaysia, in the United States, in England, in France, they work together, and it was really impressive. Thank you, guys. And since I have this word, I would also say hello and big thank to company Gero.ai, which is not here with us right now, because the CEO of Gero now is having his birthday. So I do believe, Peter, that you're on your birthday party. Congratulations. But Gero.ai supported us again for the second time, even though they didn't have the challenge this time, but they supported us in many aspects. So thank you, guys. Thank you, all the team. And hope to see you on the further steps of the further hackathons. And that's it for today. But that's right that, that's it for today for online meetings. And for those who are in San Francisco, you're gonna continue with more network sessions and one more mini hackathon. And we give you to the Lawrence, Kevin, Katya, please help Misha, of course. And my special cuckoo to all the friends in San Francisco sitting there in the auditorium right now. Katya, Misha, Artur, Gulia, hello. I hope you enjoyed this event. And as Alex said, let's keep in touch. We're gonna continue building the community. We're gonna continue to support you. And we will definitely update a lot of things on our website to provide you with all the information regarding the finals, the presentations, and the info about the teams, so that you can connect to each other and continue your collaboration. Thank you, guys.
A big thank you also to all of the organization committee, Alexei, Vita, Katya. Thanks to make this possible. And Lawrence, I give it to you.
All right. Hi, everyone. So if any one of you is interested to check out the longevity floor, I saw a bunch of hands earlier, but now I see everyone is by the food and snacks. So let's do a tour of the longevity floor. In the next 5 minutes, you'll find me in this corner. Come gather here and we go see the longevity floor, okay? And we can also discuss about Viva City, the longevity city that I'm building, if you'd like. Thank you.
And guys online, bye-bye. Thank you for this night. It was the pleasure of us, definitely. Thank you. Bye.